Hello everyone, let's start with the next problem of your third module, symmetrical components. The positive, negative, zero sequence components of line currents are, they have given data, one is 20 angle 10 degree and then IA2 negative sequence component 6 angle 60 degree and then zero sequence component 3 angle 30 degree. For the calculation point of view, I converted into rectangular form over here. So A plus JB form. So we need to calculate line current. So we need to calculate line current in the sense we need to know the formula of IA, IB and IC. So already we derived the equation in the first introduction part. The matrix IA, IB, IC is equal to 1 1 1 1 1 1 A square A square, and then IA naught, IA1, IA2. Already we discussed already we derived the equation in previous classes. So this is the line current components. This one is a matrix, A operator. This one is a sequence, positive sequence, negative sequence and zero sequence components. Line current in terms of sequence components. So if you want IA, use this formula. If you want IB, so next slide we have formulas, and then IC, just multiplication, matrix multiplication, we get IC also. So after substituting the values of IA, IA naught, IA1, IA2 and then IA naught, we got the value as 27.25 angle 21.88. If you want to calculate IB, IA naught plus A square IA1 from the matrix, okay, from the matrix multiplication we got this one and IA2. Similarly, substitute all the values and then we will get the value as 20.1 minus 120.7 degree. If you want to calculate IC, line current, IA naught is plus IA1 plus A square IA2. This is a formula we use, and once again I revised over here. If you want IA, IB, IC, use this formula 1 A square A, 1 A square, operator A, IA naught, IA1, IA2 are the zero sequence, positive sequence, negative sequence components respectively. So you just substitute the values given from the given data, you will get the final answer is 13.7 angle 120 degree amperes. So next we'll discuss relationship between the sequence components of phase and line voltages in a star connected system. It looks like a star, okay, 3 star, we can say 3 star. So and VA, VB, VC are the phase voltages having the phase sequence of ABC as shown in the figure. So phase sequence ABC I choose ABC. Okay, the line voltages system are VBC, VCA and VAB are the elementary vector algebra from the diagram. 3 line voltages VBC, VCA and then VAB. So by the voltage drop across VBC is VC minus VB, and then voltage drop across CA is VA minus VC, and then VAB is equal to V minus VA. So just for derivation purpose I converted into VBC is equal to VA vertex, and then VBC is equal to VB as a vertex, and then VAB is equal to VC I have taken. So from the previous data, VA is equal to VBC, VC minus VB, so just I equated all the values. So if you want positive sequence components in the line voltages given by, so positive sequence component in the terms of line voltages, these are the line voltages VA, VB and then VC line voltages. VA1 is equal to, you just substitute VA value and then VB value and then VC value, just substitute, you will get the required equation. So finally we got the formula. So positive sequence component is equal to J root 3 times positive sequence phase components. So positive sequence components of line voltages, this is line voltages root 3 times positive sequence components of phase voltage. This is phase voltage, this is line voltage. Okay, this is line voltage. So finally we got VA1 is equal to J root 3 VA1. I mean line of positive phase sequence of line voltage is equal to J root 3 times of positive sequence phase voltage. Similarly, so by common sense, we can say positive sequence we got J root 3 VA1. Definitely we'll get a negative sequence minus J root 3 VA1. So let's solve, let's derive the equation. This VA2, the formula is 1 by 3. I mean phase sequence, negative phase sequence in terms of line voltages. So VA, VB, VC. I mean phase sequences in terms of line voltages. So just to substitute VA, VB, VC values in the require equation, just to substitute, and we got the value as minus J root 3 into VA2. So positive sequence over and the negative sequence over, obviously zero sequence will get zero answer because 0. So VA naught is equal to 1 by 3 VA, VB, VC. Zero sequence components in terms of line voltages is given as this one. VA, VB, VC substitute will get 0 value. So just to cancel each other, all the values are cancel each other. VA naught is equal to this value. Therefore, it is evident from the above equation, zero sequence components of line voltages is 0. So finally, we'll summarize. So this is the positive sequence components J root 3 times. This is the negative sequence components minus J root 3 VB2. So VB naught and VC naught are 0. So from the derivation, just to remember these values.